All right, welcome, wonderful people. Let's get started. So yesterday, or I should say in the previous lesson, we had stopped right about here with classifying polynomials. So what we have to do is we explain which degree each of these are and the number of terms. So we got to classify them by those two traits. All right, so first off, let's go ahead and look at number 17 and get the degree from there. So we have a 2 degree, 1 degree, 0 degree. And again, the degree is the highest power in the polynomial. So the highest, if you look at each of the terms, look for the highest power, which in this case, it is a 2 power. So this one would be a quadratic. All right, now we also have to identify the number of terms. So I have 1, 2, 3. So a term was anything that is separated by a plus or a minus. And just to give you an idea, you can also circle your terms, but make sure you include the sign with your terms, because if you were going to say needing to rearrange your polynomial, you could easily do so with the term. So the term has to go, sorry, the sign has to go with it, the positive or negative sign, or the plus and minus sign need to go with the number that it's paired with. All right, so in this case here we have 3 terms. So tri means 3. Like a tricycle has 3 tires. All right, there we go. Now let's go ahead and move on to the next one. So this one only has 1 term, so that should make it pretty easy. But we can easily see the power. So in this case, it is a 4 power. So we would call it quartic, as in quarter, meaning 4. So quartic. And this one would be 1 term. So it would be monomial. So it's a monomial because, well, if you think about mono, like a mono train, a monorail has only 1 track. Monopoly means run by 1 business. So mono means 1. All right, give an example of a cubic binomial. All right, so we need something that is cubic. So in this case here, I'm going to go with, I'm going to pick a random number. Let's go with 3. 3, and it says cubic, so it needs to have a 3 degree power. So I'm going to go ahead and add a 3 degree power in there. So 3x to the 3rd plus 7. And, you know, I could really do anything with this. I could leave it like this. All right. I could just, I mean, even if it was just basically plain old 7, it would still be a binomial because it's cubic and it's a binomial. But, you know, maybe I could add an x in there as well. If I really wanted to, I could throw a 2 in there, and all 3 of those would be good answers. But I'm going to go ahead and just leave off the x for now, because it is what it is, and it works out. All right, let's see. Give an example of a linear monomial. So 1 degree and monomial, so it's only got 1 term. So what could I pick? Well, let's pick a negative number. We haven't picked any negative numbers in a while. And we could go ahead and put 5x to the 1 power, because a linear has 1 power. But you know, we don't really need this either, okay? We don't really need to say 1 power, because anytime you have something, it is always to the 1 power. So x is always to the 1 power. The only time you do not have any power is if you have something like this 31 right here. This 31 does not have any variables, so therefore it does not have any power. All right, so that's it for this one. Let's go ahead and move on to the next type of exercise. So we are going to add and subtract polynomials. So for adding and subtracting polynomials, we will combine like terms. And this one says to watch out for the subtraction problems. And I'll go ahead and explain that in just a minute. And write your answer in standard form. So we got to make sure that we put this in descending order. And let me go ahead and reiterate this here too. So like terms have same variables. Well, maybe I could put this, they have the same variables and they have the same exponents. So they must have both of those things. They must have same variables and same exponents in order to be considered like terms. Okay, so let's go ahead and go through this one. The adding ones are actually pretty easy because you just combine all of the like terms. So let's do what we did earlier and start with the highest power. So in this case here, we have a 2 power, 1 power, 0 power. And 1 power, 2 power, 0 power. So it looks like the highest power in both of these is going to be 2. So let's go ahead and combine some of these. So I have a 2 power here, a 2 power here, and a 1 power here. So let's go ahead and go with the 2 power. So that's 3x squared plus x squared. So that would be 4x squared. Because 3, and remember, if you do not see a number in front of the x, then it is considered to be 1. Well, actually, it's not considered to be 1. It is 1. So there we go. Now let's go ahead and go down the line and go to the next highest power, which in this case is a 1 power. So I have 11x and negative 5x. So 11 minus 5 will be 6. So plus 6x. And now let's go ahead and work with our regular numbers, what we call our constant values. 4 minus 13 is negative 9. And there we go. All right, let's go ahead and do the same with this one. I'm going to go ahead and underline this one with a 3 power, 2 power, 1 power, 2 power, 1 power. So this allows me to see the powers pretty easily. And you don't have to do this. I just do this so that way you can see which numbers are being added. So again, start with our highest power. So in this case, we have 9n to the 3. Let me go ahead and put the 3 power on there. And that's the only one we have that is 3 power, so it stays the same. Going down from 3 power, we go to the 2 power. So in this case, I have negative 4 and negative 2, which is going to be negative x. And I'm going to put the square on there. And then go to the 1 power. So again, we work our way downwards in the power. So 2n plus n will be 3n minus, because I can tell right now that 10 is the bigger number. It's bigger than 7, not bigger, not greater, so be careful with that. 7 minus 10 is negative 3. So there we go, we are done with that one. Okay, now it says to watch out for the subtraction problems, and this is something that I see quite often as I'm grading papers, or anytime I get work from anybody. Most of the time, if something goes wrong, it's usually something like this. So anytime you are subtracting, you have to make sure you are minusing everything in this group. So this 2k squared, it's being minused. The 2k, it's being minused. The 17, it's being minused. Okay, we are subtracting all of those pieces. So one thing that might help out is we could rewrite it so that we have all of them are already going to be minused. All right, make sure you check it again. Make sure you are changing the sign of everything. So this minus here, okay, this minus here, and this should be changed to the opposite sign, which we did not do. So make sure you check it, okay? That is one thing that I see quite often. So I rewrote it, and I'm gonna cross this out so that I do not use it again. Now from here, I'm gonna go ahead and underline them again. So 3, 2, 1, oops, I needed 2 on there. And here I have 2, 1, and no power. All right, so I think we're ready to go ahead, and now we are ready to combine our like terms and show our answer. So I have no other 3 powers. I only have one number that is a 3 power. So I'm going to go ahead and put that one down so we don't, that way we're not using it again. And then going down, so here we have 2 power. So negative 2k minus 2k. So negative 2, put them together, you get negative 4. Oh, and one other thing is that the power does not change, okay? One common misconception that I usually get is if you are minusing a k squared, then it becomes 0. No, when you are adding and subtracting, the powers do not change. But that's not to say that sometimes things don't just completely fall out. Like, let's look at this next one here. I have 2k minus 2k. 2k minus 2k. So in that case, it would be 0k. It would be 0k. But we don't really need 0k here. 0k does not do anything, okay? There's no real benefit to having that 0k because anything times 0 is just going to be 0, and we don't really need it in there because of the identity property of addition says anything plus 0 is not really going to change anything, so we don't really need it. So we're going to skip that term and move to the last one, which I only have one regular number, one constant value, and that is 17. Actually, in this case, it would be, oh, wait. I think that would be negative 17. Because if I change everything to a minus, that is going to cause it to be negative 17. So be careful with that. Don't be afraid to check your work, okay? Always check your work. It takes 4 seconds to check it, look at it, give it the sniff test. Does it seem okay? All right, if it seems okay, let's move on. All right, I'm gonna go ahead and do the same thing with this side here. I am going to distribute the negative. So I'm gonna reverse the sign of everything in the bubble. All right, and let's go ahead and put that in there. So if it's a minus 5y, we're gonna have to add plus 5y. If it's a minus y to the 3, we're gonna have to add y to the 3. All right, so there we go. I reversed the sign on everything. Double check it, make sure we actually reverse the sign on everything, which to me this looks okay. All right, let's go ahead and get ready to work with our answer here. So start with your highest power, which in this case is y to the 3. And moving down, we have y to the 2. So 4y squared and negative 2y squared. Put those together, you will have 2y to the square. And going down, so we did the 2 power, let's go to the 1 power. I have 5y and 1y. 5y and 1y will be 6y. And last terms, so look for our constant values, the ones that do not have any variables. Negative 3, negative 1. Put them together, you will have negative 4. There we go. All right, so on this last one, it's kind of a weird question because it says subtract this from that. So it wants us to do some subtracting. Now, I think in this case, most teachers would probably recommend to write this like off on this side here where you get negative 10, A, B, and the rest of all this over here. But, and you could do that too. You can do that, write it on negative over here. But I think you can get away with just reversing the sign. So in this case here, we need to make everything in the bubble, in this first parenthesis, opposite. So instead of negative 10ab, we get positive 10ab. And instead of 7a squared, we're going to have negative 7a squared. And then, let's see, negative b squared, that would be positive b squared. Okay, and I'm gonna go ahead and write all of this on one line right here, because we are still subtracting it. We reversed all the signs, so that is gonna mean, that does mean that we are subtracting it. So plus 8b squared, and you don't really need to do this actually. I could easily just do this looking at the, there we go. So sometimes I like to put everything on one line just so that way it's a little bit easier to read. But we still have to combine our like terms. Now it says to put it in standard form, but there's kind of a little bit of a problem, and that is if you look at this first term, that's a 2-degree term. It has 2 powered, because remember, a to the 1, b to the 1. If you combine the powers, that counts as a 2-power term. 7a squared is also 2 power. B squared is also 2 power. This is also 2 power, and that's 2 power. Everything is 2 power. So I have 6 terms, and they're all 2 power. So how do I put them in order if they're all 2 power? Well, standard form also means that instead first goes degree, right? So the power goes first. Then, I should have said alphabetical. Power, then alphabetical order. Okay, so every term is represented by a letter, and those letters can be placed in alphabetical order. So in this case, I'm going to use power of 2 in terms of a. So I'm going to start with the a term first. So I have negative 7a squared and negative 2a squared. Put those together, and I have negative 9a squared. Now again, I'm looking in terms of a, so the next power down from a squared is a to the 1. A to the 1, a to the 1. So the next term in this is going to be ab. So 10 plus 1 is 11ab. Because again, remember, if you don't see a number in front of your variable, it's considered to be 1. And lastly, even though again, this is still a square number, and you can easily see the square, in terms of ABC order, it is the lowest on the line. So b squared plus 8b squared, that would be 9b squared. And there we go. That's it for this one. I think we are ready to move on. Let's go ahead and go on to multiplying polynomials. So when multiplying polynomials, here are the steps that you should follow. So basically the first step is to multiply. And that means either use distributive property or use FOIL. All right, so FOIL, if you remember, that's something we've covered quite a lot. That is the first, outside, inside, last property. And then we also have the FOIL and distributive, And then we combine like terms. So after that, you basically treat it like you're adding, like we just did, okay, in the previous exercise. So combine your like terms, just like we did in the last exercise. Make sure they have the same variable and the same exponent. Write your answer in standard form. So again, from here, steps 2 and 3 are just like we did with this exercise. And again, I forgot to kind of mention that in this slide is that they must have, again, the same exponents. So what I mean by that is, ooh, you know what? I just noticed something. I put X here instead of N. Small thing, but I'm going to go ahead and fix it. So even though this is a K to the 3 and this is a K to the 2, we cannot combine them. This is Y to the 3, Y to the 2, Y to the 1. They do not have the same exponent. So these are not like terms. All right, you probably could have figured that out on your own. So anyway, let's go ahead and do this. So when it says distribute, it's actually referring to something that's a little bit more advanced. Okay, so it's not like the regular distribution where you have like a binomial, like if I had 5, just as an example, like if I had 5x minus 7 and I multiply both of these by 5, it is kind of like that, but in this case, it's going to be a little bit different. So FOIL has a nice little name to it, right? Because it stands for first, inside, outside, last. Wait, oh. Well, it would still work that way. First, outside, inside, last. But it has a nice acronym to help you remember which ones in which order you multiply them in. So I'm going to come up with a new method, and I'm going to call it the first, middle, last. So I call it 1, 2, first, middle, last. So what I'm going to do is I'm going to multiply each of these so by 1. So grab this W and multiply it times the first, 1 times the middle, 1 times the last. And then I'm going to need to do the same thing with number 2. So the second number in the binomial, multiply that times your first number. So in this case, -7 times the first number, -7 times the middle number, and -7 times the last number. This means I should have 6 terms in my next, in the next work. All right, so let's go ahead and do that. Now, I'm going to use a stacking method, which I think is actually very helpful. And if both of your factors, both of your groups, all right, this group and that group are in standard form, then this should work out. So let's go ahead and do this. So 1f, so w times w squared, so that would be w to the third. Okay, and then 1 times the middle, so this is w times 2w, so this would be plus 2w squared. Oh boy, what? Okay, there we go, finally. And then third is 1, because again, I got to times all 3 of these by w. W times 1, so this would be plus w. All right, now I'm going to stack these numbers, and there's another method you could also use called box method, but that's kind of a lesson on its own, and I think if I were doing a regular class during a regular year, I would take a day to go over box method because I think it is a lot more helpful and much easier to understand. But I think you can get this one here. Now, what we do is we go with number 2. So 1, 2. So now we're doing the second row. And I'm going to multiply all 3 of these numbers by -7. So -7 times w. So that would be -7w squared. Whew, okay, mouthful. Now I have to multiply number 2 by m. So this is -7 times 2. That would be -14 w. Oh, actually, that would only be 1 w because this 7 does not have a w. And since I only have 1 w, that would be w to the 1 power. Okay, now -7 times 1, and that would be -7. Okay, so now I have managed to add, I did both rows and both groups. So again, anytime you multiply groups, you have to multiply everything in this group by everything in this group. And this is just a great way to remember how to multiply this. And you guys being teenagers probably already kind of have a way to remember this phrase here. So let's go ahead and add these. So if you notice, look at the powers, W2, W2. They line up. And W to the 1 powers also line up. So W minus 14W. This allows us to easily add these in. So that's exactly what I'm going to do. We're going to add these in. So just like you add a large number, W3 plus nothing, or plus 0, right? That's going to stay W3. And let's go ahead and do this one. 2 minus 7. 2 minus 7 is negative 5. W, and again, when you add or subtract, the power does not change. Adding or subtracting only changes the coefficient, the number in the front. All right, so W minus 14W, that would be negative 13W. And negative 7 has nothing to combine with, so it stays the same. So there you go, you're adding them by column. And that's a fairly easy way. And if you make a mistake, you can easily look at which row you are needing to work with. So row 1, so again, this is your row 1 and row 2. Row 1, row 2. And then again, first, middle, last, first, middle, last. Okay, so let's go ahead and move on to this one. Now this one's a bit of a weird one because looking at it, it looks like we actually need to do two things. So this here, if we look at our order of operations, these two are multiply, these two are multiply, and this is an add. So PEMDAS says we should do the multiplication before the addition. So I'm going to multiply these two and multiply these two, but keep this the same. So right now I'm going to go ahead and use my FOIL. So 2x times 4 is 8x. And let's see, let's look at this one here. 2x times negative 9. Okay, this is not in order. It's not in standard form, because this one here, the 9 and the 4 should be reversed. Okay, but let's keep going. So first outside, inside. So now we're on the inside, plus 4, and last number in each group. So this would be negative 9x. Okay, now I am going to put this in. I'm gonna rewrite this so that it is in what do you call that? Standard form. Sorry, I'm just getting a little. So negative 18x squared, combine 8 and negative 9. Actually, you know what? I don't need to do this. I'm looking at it and I think I can get around not doing this. So here I have the minus, and for this minus, I'm gonna move it over here so that you can see that it is a different minus. All right. Okay, you can't see, but it's a slightly different color. Now what I need to do is I need to multiply both of these by negative 2. So we got to use our distributive property. So times this by negative 2 and times this by negative 2. So you might remember way early on in the year, like probably one of the first or second lessons that we've ever done, I kept telling you, make sure you multiply this by a negative. So let's go ahead and use that negative. So I'm actually going to multiply everything by the negative. So this would be negative 6x. Oops, where did the 6 go? Negative 6x squared. And let's see, negative 2x times 11, that would be negative 22x. Now, since I used the negative here, I'm going to go ahead and delete it here, because now both of these already share the negative, right? Because what this means is subtract this and subtract this, subtract the whole group. So I'm going to put them together now. And from here, we should be able to line them up. Now, we can't use this one here where we line them up by up and down ways because, well, just because this was not in standard form. Okay, so that's what happens when your factors are not in standard form. The groups are not in standard form. So now I have to go down the line, just like I was, you know, when we were adding and subtracting polynomials. Look down here and see which ones we can do. So let's go with the highest power. So this is negative 18 and negative 6. So that would be negative 24x squared. and then x to the 1 power. So I have 3 of them, 8, -9, and -22. So 8 minus 9 is -1, -22 and -1, put those together, you get -23x. And regular numbers, it looks like I only have one regular number, and that is 4. And you know what? I think I've been a little bit bad about this, about boxing my answers. Now, on most of these, I think I wasn't boxing my answers because it was fairly obvious which ones, right? The last thing in there. And there's kind of a little bit of space, so maybe that's why I wasn't boxing my answers. But I tell students to do it, so I should be the example in this case here. So in this case here, it's big enough to where we are gonna mistake it. It is a possibility we can mistake the answer for something else. So that's why I'm gonna box it on these examples. All right, moving on, let's go ahead and do another set. Hopefully you got all this. I know it's a lot, but it's a lot of writing, but it's honestly not that tough. Okay, so with these ones here, I am going to, it looks like this is multiply, 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 multiply. And if you remember, multiplication does not matter in the order that we multiply it. That's called commutative property. So I'm gonna break these into 2 groups. Because again, I'm gonna break it into the first group, which is the first 2 numbers. So that would be -3a and -15. So all I did was multiply this by -3 and multiply that by -3. Oh, that was pretty easy. And you know what? I'm gonna go ahead and put them into groups because they are still grouped together. Now I'm gonna do this one here, but now with this one here, I have to do FOIL. Okay, I'm gonna have to use the FOIL method on this one here. So this is gonna be a squared. And let's see, I have, all right, this next part, usually when I do the FOIL, I do 1 step at a time, but I'm gonna do this one in my head. So I'm gonna do outside, which is a times 8. So that would be 8a. Inside is -2a. So 8 minus 2 is 6a. All right, and that just saves me a little bit of writing. And last is -2 and 8, so that would be 16. Now, because we're still using groups, I'm gonna have to group these together. All right, the parentheses stays for a little bit longer. So now it looks like I have a binomial times a trinomial. So in this case here, I am going to need to use the first, middle, last method. And you know, I'm gonna move these down a little bit more so that I can write the numbers so that way you can see what I'm doing. So this will be row 1, F, first, middle, last. There you go. So now I'm gonna multiply everything in this group by -3a. So let's go, I'm gonna move it over here. So this is gonna be -3a to the, all right, I have 2 power and 1 power. So this would be 3 power. And then now 1 times the middle, so 1m. And this would be -3 times -3a times 6a, so that would be -8a. And there's 1a on each of them, so that way they have a square. And 1 times the last number. So negative times negative is positive. And let's see, 16 times 3 is 48. And there is 1a, right? This first number brought in a, but this one does not, so that leaves us with only 1a. So again, this is row 1. Now let's go ahead and work on row 2. So row 2 is going to be this one here. So row 2. So multiply -15 times these 3 numbers. So -15a squared okay, and then moving on, so this is 2 times the middle, so -15 times 6a, and that would be negative 90a. But it's going to be a plus, or actually, no, it's going to be a minus. So minus 90a. And then, let's see, after that, we have 2 times the last number. So negative 15 times negative 16. So negative times negative is positive, and 16 times 15 is 240. And again, doing it this way, you should be able to line them up. Line them up so that way you can add them much more efficiently. So I'm going to add all of these together, make sure that you have the right powers over each other, and if they're both in standard form, then they should line up. All right, so let's go ahead and write out our answer. So in this case here, we have negative 3a squared because I don't have any other of these. So I don't have any other, oops, actually that should be to the 3 power. I don't know why I changed the power, but it's a good thing I caught it. All right, so negative 18 and negative 15 would be negative 33a squared. And here I have 48 and minus 90. And I think that would be negative 42a. And lastly, 240 does not have anything to combine with, so it will stay as is. And we are done with that one. And I guess we'll go ahead and box this up. That way we know it's the answer. Okay, and let's go ahead and move over to this one. So with this one, first thing I'm going to do is I am going to expand it. Right, because I need to expand it because of, well, it'll just make things a little bit easier to multiply. So I'm going to go ahead and write out the whole thing. So by writing it out, I'm able to see all of the steps. Now, some people are pretty good at this, and there are some tricks you can use to do this, but well, those can be kind of confusing, and that's a whole nother lesson all on its own. So let's go ahead and use our FOIL. Actually, I'm going to FOIL these second two here. So leave this first one the same, but I'm going to use my FOIL. So first number is 2c times 2c, and that would be 4c squared. Outside, and actually there's a shortcut for perfect square trinomials here, and that is you multiply this and then double it. So 2c times 5d. Now you got to keep it in order. So in this case here, this would be 10cd. And inside, so let's go ahead and work on our outside now, or inside, outside, sorry, the inside here. 5d times 2c. Now again, keep it in alphabetical order. 10c, oh, sorry, 10, and you might be tempted to go dc, all right, because d looks like it's going before c, but actually you always put it in alphabetical order because now you can see, look at that. We have 2 CDs. Since we have 2 CDs, I'm going to go ahead and double it. So again, I said there was a shortcut here, but I'm showing you that the shortcut, why it works. Okay, so I'm going to get rid of this because we combined like terms of our outside and inside. We put them together already. Now let's move to our last one, 5d times 5d. That would be plus 25d squared. And there we go. So we have the whole thing. Now from here, we are going to have to do the 1-2 FML method. 1-2, first, middle, last. So let's go ahead and hopefully you're kind of getting this. So 1 times F, 1 times M, 1 times L. So this is all row 1. And that's going to be, let's see, 2C, or 2 times 4 is 8. And we have C to the, looks like to the third. And then 2 times, sorry, 2C times 20C would be 40C squared. And it looks like we also have D as well, plus 50C, and I'm doing the last one now, so this is 2C times 25D squared. So make sure you pay attention to the powers. Okay, so this is d squared, so there's two of those here, and then we have 1c like that. So this is our row 1 and 2. So let's go ahead and multiply all 3 of these now by 5d. So here we go, 20, and keep them in alphabetical order. So again, even though there's d here, well, let's do the c first. C squared d. And if you, again, put them in alphabetical order, you'll notice that this is c squared on both of these and a d on both of these. All right, so 2 times the middle. So this would be 5 times 20 is 100. C and then d squared. So it looks like we're going to have a d, oopsie, d, oh, come on, square. Okay, you know what, let me just fix it like this. There we go. And it should match out. So again, 5d times the middle number, and now 5d times the last number. So this is 5 times 25. 5 times 25 is 125. Oops. Make sure we add the plus in there. And now we have to, let's see, that's d to the 3. I think that is d to the 3 because 2 d's here, 1 here, so that would be d to the 3 power. Now again, it should already be in order. Let's just go down the line and start multiplying, well, not multiplying, I'm sorry, combining like terms. Sorry, it gets really confusing to keep track of so many things all at once. All right, so now add these together. 40 and 20 make 60. C square d, and then plus the next number, which is 150, plus 150 c d square, because they're both cd square numbers again. And actually all of these are 3 power, this is a 3 power term, this is a 3 power term, and this is a 3 power term, because 1c, 2 d's, that's 3 powers altogether. And there we go, nothing to add to that last one, so it just sort of stays the same. And it looks like we are done with that one. So let's go ahead and box it up, call it the answer. And again, all 4 of these terms in that number 9's answer are all 3 power terms. But again, it goes by ABC order, so C alphabetically comes before D, so that's why we have to arrange them in this order, even though they are all 3 power. And it looks like we are nearing, well, actually, I don't know how far we are. It looks like we still have more to do, and I think this is going to be a slightly longer than usual lesson. Oh, okay, I see what's going on with these. It looks like we are going to have, instead of 1, 2, first, middle, last, it's going to be 1, 2, 3, first, middle, last. Now, for these ones, I would really prefer what I call box method, or actually, I think that's what everyone calls it. And that is to, put your terms, so you'd have like 3m squared minus 4m plus 1, and then you'd have your other one, 2m squared plus 5m minus 9. And I think that'd be the easiest way to understand to do that. And so you just sort of multiply each term where the numbers come together. But it looks like I'm gonna have to do that because I'd have to draw a whole box out, and then I'd have to basically turn this into a whole new lesson. So basically for now, I am just going to stick with the one we've already been doing. So 1 times FML, 2 times FML, and 3 times FML. So basically it's already what we've been doing, but there's 3 steps first. Okay, so we gotta have 3 rows. So let's go ahead and do this one here. So I have 6m to the 4, because 3 times 2 is 6. 2m's, 2m's. Now 1 times the middle, so this is 3m squared times 5m, which is going to be 15m to the 3rd power. And now 1 times the last, so that's 3m squared times negative 9. So that'd be negative 27m squared. And there we go, that's our first row. And again, I'm gonna put the little blue mark here, so that way you know all of this comes from here. Now, if you make a mistake, you can easily check your work this way here. It's a very easy way to look at, okay, so, 3m squared times all of these, make sure you didn't make any mistakes. And let's go ahead and I'm gonna mark it row 2 and row 3. So let's go ahead and do 1 here. So that's, actually this is row 2. So we multiply everything by negative 4m. So negative 4m times these 3 numbers here. So that would be, let's see, negative 8m to the 3rd. And I'm gonna line it up. And negative 4 times negative 5, so that'd be negative 20m squared. And again, if you do this right, and if they're both in standard form in each group, okay, if they're standard form in each group, that means that they will basically line up the way they should. So negative 4 times negative 9 is positive 36 m. And you notice again, these powers are also descending as well. And it looks like I'm gonna have to go on to group 3, which actually this is pretty easy, because 1 times anything is gonna be that exact same number, right? That's the identity property. This is why it helps to know your properties, because I'm just gonna retype everything just as is. 2m squared plus 5m minus 9. Same thing, because we're timesing it by 1. Timesing anything by 1 does not change anything, really. Okay, so let's go ahead and go through these and add all of the components together. So 6m to the 4 plus 7m to the 3. And add these 3 numbers together. So I got 3 numbers, negative 27, negative 20, so that'd be negative 47. Negative 47 plus 2 is, minus 45. Minus 45m to the 2. And here I have 36 plus 5, so that would be 41m. Oops, forgot the plus sign. And minus 9. And my computer always does this every time. Every time you go to a previous, it thinks you're trying to type the exponent. So there you go. So all your m's line up, all your m's to the 2 line up, m's to the 3. So that makes it pretty easy to add these together. Makes it pretty easy to add them together so you're not missing anything. And like I said, it seems like a lot of work, but it's actually pretty quick once you get around to it. All right, so it looks like I'm gonna have to do the same thing. 1 times these 3, 2, the second number times these 3, and the third number times these 3. But again, hopefully we're getting good at this. So let's go ahead and multiply everything by x squared. Now this one's gonna be a pretty easy one, because all I have to do is add 2 power x's on each number. So 2 plus 2 is 4, 9x to the 1, so 1 plus 2 is 3, so that's negative 9x to the 3, and negative 4x to the 2. So all I'm doing is adding 2 power to each of those. So that was pretty easy, actually. And now time for the second row. So row 2, I'm going to have to multiply everything by 6x. So 6x times negative x squared, so that's going to be negative 6x to the 3rd. And let's go ahead and move to the middle one. So I'm using the second number here. So 6 times negative 9 is negative 54. I think it is negative 54. I don't know. If you don't think so, just let me know. Okay, now 6 times negative 4. So this would be negative 24x. And again, let's try to line up the powers here. And lastly, it looks like we have to multiply in the third row. So again, third row, everything by negative 7. So this would be 7 times x squared. So that'd be 7x squared. And now negative 7 times negative 9, that would be plus 63x. And last number, negative 7 times negative 4. Okay, finally an easy one. There you go. So now they're all lined up. I'm going to line them up just a little bit better. So we have all our 2 powers, all our 1 powers, and 3 powers stacked on top of each other. Draw a line here and make sure that we know we're adding. So we're going to add these 3 rows together. And let's go ahead and put them all together. So x to the 4 and negative 9 and negative 6 is going to be negative 15x to the third. And negative 4, negative 54, and that would be negative 58. Negative 58 plus 7 is going to be negative 51x squared. And then plus 39, 39x plus 28. And that last one is pretty easy because I don't have any other numbers to add it with. And it looks like we're largely done with both of these. So let's go ahead and box them up. And we are done with these. All right, so that takes care of multiplying. It looks like we have only one exercise type left to go. And multiplying and dividing, I don't know. I think so far we're still on the easy part of this lesson. So let's cover what we do for dividing. Wait, oh wait, it looks like we got one more. Oh gosh. All right. So what do we got here? The height of a trapezoid. So a trapezoid is a shape that kind of looks like this. It's a 4-sided figure, so it's a quadrilateral. And this one here is an isosceles trapezoid, well, kind of. I tried to make both legs the same length. In fact, I could probably fix it. But that's actually not really that important. But a trapezoid looks like this. Now, it says here this is the height. So the height is 2x plus 9. And the bases, so it looks like we have 2 different bases, and this is not really that important, I don't think. But I'm just trying to show you what it would look like. So there you go. So we have a short side, long side, and the height. And the height is not the slanty part, it is the straight to the top, straight to the bottom part. That's the height. So here you go. So that we filled it out, right? This is our height. These are the bases, which there's 2 bases because they're 2 different sizes. Write an expression to represent the area of the trapezoid. So with trapezoid, I'm going to move over to the internet. And what we can do is type in area of a trapezoid. Oh, good. It's the first thing that comes up. Now, be careful with these because this is not going to help us because I cannot put in x minus 5. All right, so this Google formula solver is not going to work. So we're going to have to look up something on our own. Now, there are 2 formulas that it gives us. This is the one we don't need. So area plus base, I'm sorry, this is A, so base A, base B, so there are two bases, times H divided by 2. And that may not make a lot of sense at first, but this one might make a little bit more sense because you're taking the average length of A and B and then divide it by 2 and then times it by H. But this formula is not going to help us that much. The formula we need is this one. So we have top plus the bottom times half, then times H. And like I said, the height is the top to the bottom, basically 90 degrees from the top to the bottom. So don't use the slant height. That's what you would call the slant height. So this is the formula that we are going to need. So again, it looks like there's 3 formulas actually. So be careful and try to use the correct formula. So this means that we're going to have to multiply it. So instead of writing half, I'm going to put 0.5 just so it's easy to type it. So I have 3x minus 7 plus the other base, x plus 5, times the height. So that'd be 2x plus 9. All right, and it doesn't say anything about solving it or evaluating it, but it says to write an expression to represent the area. And I feel like this would be enough, but let's go ahead and practice multiplying some of the stuff that we have. So 0.5 times, and see, I have this 4-term polynomial. I'm gonna combine my like terms, so 3x plus x. That would be 4x, and make sure we put it in standard form just so it'd be easier to work with. And negative 7 plus 5 is negative 2. And here I'm going to go ahead and just put the same thing that we have earlier there. And so far so good. Nothing really that tricky. So 2x plus 9 stays the same. All I did was combine this together. Now, looking at this, I noticed that I can multiply both of these by half. So half of 4x is 2x, and half of negative 2 is negative 1. So again, all I did was take half of this and half of that. So that way we took care of our half, and here's we have 2x plus 9 still there. And it looks like I'm going to have to use my FOIL. And I think this will be the answer. So 2x times 2x is 4x squared. And 2x times 9 is going to be 18x. Inside is minus 2x. 18 minus 2 is 16x. Negative 1 and 9 would be negative 9. And I think we're done with this. So area of this trapezoid is equal to 4x squared plus 16x minus 9. All right, now on to the last one. All right, I understand this is a lot of information to take in as well too. So usually I think on a regular lesson, I'd kind of break each of these into their own, individualized lesson. But I'm working with the material I have. So let's go ahead and move on to the next one. And that is dividing polynomials by a monomial. So we have a polynomial, which in this case is a binomial, divided by a monomial. Here we have a trinomial divided by a monomial. Now here's the steps we got to take. Divide each term in the numerator, that is the top number. Divide the top numbers by the bottom numbers monomial in the denominator, which means the bottom number. The bottom number is the denominator. So numerator over denominator. Just to help you out. All right, so let's go ahead and do that. And then make sure we write our answer in standard form. Oh, and it looks like there's one other step. Rewrite all terms with negative exponents. So does that mean to rewrite them so that they do have negative exponents or that they don't have a negative exponents? All right, I'm joking with you. I know what it is. We want no negative exponents. So if it's a negative, we got to write it so that way it's not going to be a negative exponent, because in everyday math we never use negative exponents. It's just not a regular way that we show numbers. All right, so anyway, let's go ahead and get to dividing. So 9 divided by 3, that's 3. And remember, we use our subtracting property. So the quotient property says that if I have m to the 3 divided by m to the 1, we subtract it. So 3 minus 1 is 2. Okay, not bad. So far, so good. Now we're going to have to subtract this. So minus, because it's negative 24 divided by 3. That would be 8. And again, minus the powers, subtract the powers. 2 minus 1 is 1. And actually, we are done with that one. See, not too bad. Let's go ahead and do this and divide everything on top by 4x. So 20 divided by 4 is 5. 3x minus 1x is 2x. So let's write 5x squared. And let's see, negative 4 divided by 4 is negative 1. X squared minus 1x is going to be just 1x. Now, anytime we have a coefficient of 1, let's get rid of that 1. All right, for the same reason why when you're working with a problem and you see no number in front, you put a 1 there, or you act as if it's 1. We do the same thing when writing answers, okay? If we don't need the 1, we don't put it in. All right, now in that last term, so this is negative 8 divided by 4, and that would be 2. And I have 1x minus x to the 1, or 1 power x minus 1 power x. So in this case here, we have no more x. The x is gone. Esteed. Oh, sorry. It's gone. All right. Fresh out. Not too bad. All right. 2 more to go. 2 more exercises, or 2 more slides, I should say. All right, moving on. These were pretty easy. We didn't have to do a whole lot of extra work. So let's go ahead and do this here. Oh boy. So here we have a negative 1 power. So remember what negative 1 power means. To get rid of the negative 1 power, you move it to the bottom side of the, or you move it to the opposite side of the fraction. So if there was one great big fraction, let's move this down here. So basically it means this whole group has to switch sides and go to the other side of the fraction. So basically it looks like we're just dividing it. All right, now let's go ahead and divide everything by 2ab. All right, 14 divided by 2 is 7. 4 minus 1 is 3. And let's look at the b. 3 b's, 1 b, so 3 minus 1 is b to the 2. And let's do the middle one. So negative 20 divided by 2 is negative 10. 2 minus 1 for the a. B is 2 minus 1, so that's going to be, loses 1 of each. Now this last one's kind of a weird one, and this one here I get a lot of mistakes on. A lot of students will say it's 0 because 2ab divided by 2ab is 0. No, that is not true. Any number divided by itself is equal to 1, not 0, because it's not 2ab minus 2ab. by, I forget what, let's see, I forget what this rule is called, but I use it all the time, and it's 5 divided by 5, or any number divided by itself is always going to be equal to 1. Again, the name kind of escapes me for now, but I know that it's one of the big properties. And there we go, we are done with that one. Now here's where things start getting a little bit weird, okay? I don't like it when things get weird. But, you know, sometimes it's just like this. So let's go ahead and do this problem here. So here I have 30 over 12. 30 over 12. Now 30 does not divide by 12. So again, if you can't divide it, we must reduce it. Think of the largest number we can divide by 30 and 12. That would be 6. Divide 30 by 6, divide 12 by 6. So I end up with 5 over 2. Okay, and I'm going to go ahead and turn this into a fraction. And moving on, so here I have C8 and C2, so that's 8 minus 2. So that will be C to the 6. Now for the D, so D3 minus D1, so that's 3 minus 1, that would be D squared. Now 36 and 12 will divide. They divide because 36 divided by 12 is 3. Oops, I forgot to unexponent it. So negative 3 and 6 minus 2, C to the 4. For this variable, 2 minus 1, oops, that looks like it would be, oops, come on. Now I'm starting to mess up the typing. There we go. Plus, and it looks like we're going to have another, I keep undoing this. Why does it keep redoing this? Plus C over 2. Because in this case here, let's look at 6 over 12. 6 over 12. I cannot divide it, so I'm going to have to reduce it. Divide by 6, divide by 6. So we get 1/2. And let's go and work with the power. So 3 minus 1. And for this variable, 1 minus 1 is 0. So I actually do not have any more of that variable left. So we end up with something like this. Now, if you want, you can go ahead and leave your answer like this. But if you want to be a little bit more appropriate about this, I'm going to go ahead and show you the correct way to write this. And that is to put the fraction all over 2. So basically, I just spread the 2 through all of these. And for this last one here, and let's see, now instead of saying 1/2 C, we could say C over 2. And I'm just making this a little bit better. And I understand that maybe not everyone will understand exactly why or what I'm doing this. So if you leave your answer like that, I'm fine with that, okay? But this is the slightly better way of writing it. But if you even just put it close to something like that, then again, I will accept it. Okay, moving on to the last problems. Now these ones are kind of the same ones, a lot of the same things that we have in the previous exercise where we have some of these that won't really divide, but let's go ahead and try our best to divide as many as you can. 30 divided by 3 is 10. X's, so I have 3 minus 2. 3 minus 2 is 1. All right, no problem there. Negative 12 divided by 3 is negative 4. X squared minus x squared, it means we have no more x. Now again, here's where things get a little bit dicey because 9 divided by 3 is 3. But check out the x. I have 1 minus 2. And that means that we end up with a negative exponent. And that is the negative exponent rule that we covered in the previous lesson. So the negative exponent rule says that if we have a negative exponent, we have to switch the side of the fraction that it's on. So I'm going to go ahead and rewrite this as 10x minus 4. And I'm going to have to write this last part as a fraction. Now remember, only the x is going to have to switch sides of the fraction. So there we go. This is the correct way of writing our answer. All right, moving on to the last one. 40 divided by 8 is 5. 3 minus 2 for the m. 3 minus 2 is, well, 1m. N, so this is 4 minus 5, and we are going to have a negative exponent again. All right, so negative 24 divided by 8, that is negative 3. And let's look at the n. I have two n's, or sorry, m. 2 on top, 2 on bottom, 2 on top, 2 on bottom. So there should be no more m. Looking at the n, n7, n over n5. So that's 7 minus 5 is 2. So I should have 2n left. Now we run into the same problem where we have a negative exponent. So that means I'm going to have to move this one to the bottom of the fraction. And there we go. So now it's on the bottom of the fraction. All right. Whew. Quite a long lesson. I don't think I could have gone any faster. I feel like I tried to choose a speed that was quick enough to get into the lesson in the regular amount of time that I usually try to get things in. But this has been a little bit of a longer lesson, and I understand that it is kind of a longer lesson, which is why I split it into two parts, and I didn't want to go so fast that nobody could understand what I was doing. So I tried to pace it as good as I could. Anyway, so that is it for today, and I will see you later. Goodbye now.